Thank you, and I'm delighted to be here. Thank you, Orlando, for inviting me. I'm interested to know, I had to come in late, I apologize. I had another event this morning, and I see all these wonderful research posters here, and I'm interested to know who here is an undergraduate student. Thank you. And who is a graduate student? Okay, the vast majority. And who's a postdoc? Okay, and a faculty member here in the room. Okay, so there's a lot of research brain power in this room. And my goal today, here we go, is to talk about this theme, connecting and empowering next-gen innovators. And my perspective that I'm going to be bringing to you today is through developing entrepreneurial capabilities in very smart researchers. So I'm going to controversially, perhaps, argue against one thing that our last keynote said. I agreed with most of what he said, but one thing he said is that you have all the ingredients right now to be impactful innovators. And I would say that if you are researchers, if you are developing something new to the world that can solve some of the pressing problems that we face to create a sustainable future, that you may not have all the ingredients yet if your experience has been largely in a research lab. And yet, from that research lab, you have the agency and the power to create path-dependent decisions that can create a path for your innovation to make global impact. So, a little quiz to start us off with. Who here recognizes the star scientist on this screen? If you could raise your hand. Do you recognize who this is? No hands in the crowd. There's somebody here who recognizes, but I'll say this is Professor Stephanie Simmons. So she is a CRC chair in quantum computing. Can you hear me properly? Yeah. She is one of two scientists across Canada that leads the National Quantum Strategy. She has been the co-founder and now the CSO of a quantum computing company that has a revolutionary breakthrough possibility for quantum computing, low-cost quantum computing. And they just raised, maybe 2 months ago, 100 million US to fuel this dream with major strategic alliance partners, including Microsoft. And Stephanie, incredible scientist as she was, didn't know how to create that innovation impact from her research until she took it upon herself to go and get that training. And so when she first came as a CRC chair, who had a big CFI grant coming in for $20 million for her lab, she had the humility to walk into a room, into a program, the Invention to Innovation program, every week, one night a week, for a year, to be able to develop strategy around her research and to equip herself with the skills to make real global impact. And of course, a professor never does it alone, very rarely does it alone. They usually make that impact from their research with graduate students and postdocs who also understand the research, but need to develop more things to make, to be able to make global impact and to do entrepreneurial and innovative product development. And so this is Evan McCrory. He was a postdoc that was co-supervised by Professor Simmons and myself through an NFRF, a New Foundations and Research Fund Discovery Grant. And he went on to also develop those skill sets. And because the company now was founded and they already had a commercialization strategy, he instead spent his extra efforts and the learnings in that course to write a paper together with his supervisor, Professor Simmons, with myself, and with another professor at the University of Calgary, about how the whole ecosystem in North America was emerging with all the different types of technologies and their business models, which was a very rare set of knowledge to be able to combine the deep technical excellence and expertise and perspective with the innovation perspective and the innovation ecosystem perspective. And that's been making a lot of impact, including on national strategy. Second test, this one may be closer to home. Can you raise your hand if you recognize this star scientist? I'm seeing a few. You want to shout it out? Oh, it says it. Darn. I missed that part, thank you. So this is Steve Holdcroft. He is, again, a Canada Research Chair, an incredible innovator in the clean energy space, was also platform director for fuel cells at the NRC IFC Center here for about a decade. He and his co-founder, one of his co-founders, another one is in the room here today, have been recognized just last week with a National Innovation Award from the Governor General of Canada. And he, in his research for 30 years, having things that were really impactful, hadn't started a company until he had a PhD student who was interested in starting a company with him, and other people affiliated with his lab, postdocs, and colleagues affiliated with his lab that were willing to take the steps to go out and step into their uncomfort zone, to be able to become innovators and mobilize breakthrough research. Now, why is it so hard? You know, we can think about the fact that people start companies all the time, but they don't start companies about breakthrough research all the time. So breakthrough research, the kind of thing that maybe several of you are involved with, can enable totally new properties. It can be an order of magnitude change in a specific attribute. It can enable products that never would have existed before. And it can also do so across a broad range of sectors. And so that, although it opens up enormous opportunity, both deep changes and broad changes, it's also really challenging to commercialize. And if you only have a scientific perspective, or if you only have a scientific perspective and try to throw something over the wall to someone with a business perspective, you are likely to fail. And why are you likely to fail? Because there's high technological and market uncertainty, and because the time to commercialization and the red circle, the amount of money that somebody has to bet before you commercialize, is very long. And so getting investors to bet for that period of time, often 10 years, is challenging. And you have to make the early steps in the lab, in the way that you think about prioritizing markets, in the way that you think about creating a currency, usually with intellectual property, to be able to step across that challenging terrain. Here's a study that I did with a venture capitalist who also has a PhD in materials engineering and had invested in hundreds of materials startup companies, and I've studied hundreds of materials startup companies. And we looked and tried to show the comparison for that schematic that I just showed you. And you could see that compared to a software company startup or that would be an extreme, you can see, and I'm not sure how I can show a pointer. Here we go, not really. So you can see that there's a difference in R&D costs, but the real difference is in these commercialization costs. You know, for IT, maybe $1 million. When you're trying to commercialize in biomed, could be $1 billion. And in advanced materials, it's often $100 million before you have, we talked about pulp and paper processes. When you're scaling them up, you need to build a pilot plant. You have a lot of technological uncertainty to overcome, as well as not knowing exactly whether or not your product's going to be viable in that marketplace. So what can you do? Well, what you have in spades are these type of intangible assets. So you have international networks. You have academic excellence. You have human capital. You have often patents, and you certainly have papers. But do you have the right patents? Have you carved out the right space? Have you thought about the long-term future as well as the short-term prioritization? And does that show itself in your IP strategy? Are you partnering with the right companies? Have you mobilized those international social networks of your founder, of your founding team, of your PI and your colleagues? Because if you have these, what we call spin-off endowment intangible assets. These are going to help you actually cross that period of time to be able to get investment, create value, demonstrate that value, and be able to create that global impact. Now here's an easier test. Again, it does have his name, but also this person's face, I'm sure, is familiar to many of you. This is Carl Hansen, was a professor here, and also an undergrad here before that, before he went away to Caltech for his PhD. Was a professor here since 2005, doing interdisciplinary research, running a lab, doing some of these technology market matching skills. In fact, we did a study of the 20-year overnight success story of Accelera, and you can see that the actual entrepreneurial capabilities exhibited by Professor Hansen and his graduate students and postdocs started much, much earlier than the company was founded in 2012. And if you look to the top of the screen, you see where those entrepreneurial capabilities, we found evidence of them. And that there was an incubation period here at UBC before the company actually launched out in the world without the supports of a university. So this is a way to actually span that hard period of time. And I'm going to show you a little bit more about these types of capabilities. So what are they? It starts with the star scientist, entrepreneur, and the lab members, you here today. And there's 4 key capabilities that you can actually demonstrate. You can learn about them, you can practice them with your research when you're making commercialization strategy to create real impact from what you're doing in the lab. The first one is technology market matching. We heard a little bit about it earlier today. The second is how you develop IP strategy, how you claim and protect an invention. The next is how you attract and mentor the founding team. And usually that's the PI who's doing that from both the business side and the science side. And the last is the strategic timing of when you decide to form your firm and when you decide to actually go out of stealth mode and go out into the world. And so those capabilities work, of course, in concert with your university technology licensing office or UILO. They work in concert with how you patent things, your collaborators, and with the experienced entrepreneurs and executives in your community, as well as venture capitalists. We can teach these things. We can learn these things. And so 9 years ago, we started here in Vancouver a program to try to teach these things, to try to be able to walk the talk of our own research, which said this could be learned, and developed a program for scientists and engineers. There are people in this room who have been through it, including 20 profs across Canada, and postdocs, including here's an alumni from this building here, Elena Gropa, who's now in Switzerland, creating impact in her innovation ecosystem there. But what we found when we looked at the alumni over those 9 years was that they were not all starting new startups. That wasn't the way, actually it wasn't even the predominant way that people were creating value from their research. In fact, fully 50% of them were becoming champions of innovation in industry. And that means that they were being able to increase Canada's and whatever ecosystem that they were in, they were able to increase their innovation record in the zone that the domain that they are operating in, that they were able to lead either new business development initiatives or new product development in a way that their boss felt that they understood both the business side and the scientific side, and are creating a lot of change in ways that benefit the ecosystem as a whole, but also benefit the researcher. And lastly, people who stay in academia on a translational research path, but change the way that they frame projects, change the way that they, the things that they ask their lab mates, their lab students to do. So briefly, these are 3 different paths that we try to have nurture, value equally. And we find that in the programs that we develop, and this is now across the country, that these skills are learned, but the people on these pathways might start out thinking they're going to start a company, but actually turn to being an industry innovation champion. Or they may think that they're going to stay in academia, but actually turn to one of these different pathways. And so this is actually to be celebrated across the careers of individuals. Here are some people who have trod that path. There's one in the room here, Dr. Rahul Singh, who is now leading up BC CAI, the BC Centre for Agriculture Innovation, but many different paths you could take to be able to be someone who is connecting the research world and ecosystem with the innovation ecosystem around us and making impact from our research. As I said, we have collaborating partners and institutions across the country, but these programs, with the partnership of MyTax, a very valued partner in from 2019, are available to every graduate student across the country. There's an application process, but this is something that you could be involved with. There is also, I know my colleague, Professor Chad Sinclair here, who is running a new NSERC Create here out of materials engineering and chemistry here at UBC that has also incorporated the I2I as part of their training. So there may be opportunities there for you. If you do want to find out more, some websites and some links, including the cohort that starts in September. The application is the end of the month. It's May 28th. A very simple application where you talk about your innovation idea and your research and your motivation. So to conclude, I'd like to say that in order to really empower yourself to take that next step, to go from impactful research to impactful innovation, to help create a more sustainable future from nature, I encourage you to develop entrepreneurial capabilities, to step outside of your comfort zone, and to make Canada and the world more innovative as a result. Thank you.